Okay, so we're going to talk about complex numbers. Now, complex numbers is another type of number system, but that complex numbers can help us with solving quadratic equations that have no real solutions, and you're going to see this in a future lesson. Well, let's review something with terms of square roots. We all know that the square root of 49 is 7 because 7 times 7 is 49. In a previous lesson, we saw that the square root of a negative 36 is not a real number, because no number times itself is a negative 36. You might say, well, what about 6 times 6? Well, 6 times 6 is a positive 36. And you might say, what about negative 6? Well, negative 6 times a negative 6 is also a positive 36. So there's no real number times itself that's going to be a negative number. It's always going to be a positive number. So, and then remember also, when you put negative 36 in your calculator, when you took the square root of negative 36, you got this error. All right, so it's a domain error, so you can't take the square root of a negative number and expect to get a real number. So what we've done is we've defined what's called a complex number system. And before we talk about a complex number system, what that entails, let's talk about what's called an imaginary unit. Okay, an imaginary unit. All right, now this is a definition, so you have to take for granted this definition. So in order to talk about complex numbers, we had to define a basic term, and that's called the imaginary unit. And the imaginary unit is this idea. So it is written as I. Okay, it's written as I, is the italic I. Italicized I, if you were to type it out. And it's a number I whose square is negative 1. So the imaginary unit is written as I, and it's whose square is negative 1. So in other words, I squared must equal negative 1. So that's how we define the imaginary unit. And so when you take the square root of both sides, you're going to get that I is the square root of negative 1. So that's how it's defined. So I squared is equal to negative 1. So the imaginary unit, which is written as I, is the number, let me write this, is the number whose square is negative 1. So I squared equals negative 1, and I equals the square root of negative 1. So you take the square root of both sides, that's what you get. I equals the square root of negative 1. Okay, so this is your basic terminology. This one right here is the one that you're going to need with what we're about to talk about. Okay, so for example, let's go back to the square root of negative 36. All right, so I know that negative 36 is not a real number. I know that negative 36 is not a real number, but I can write it as an imaginary number. So in other words, I can write the square root of negative 36 as the square root of a negative 1 times 36. Okay? And then based on what we did in the previous lesson, I can rewrite the square root of negative 1 times 36 as the product of two radicals. The square root of a negative 1 times the square root of 36. And so the square root of a negative 1, remember, is defined, square root of a negative 1 is defined as the imaginary unit I. So I get I times, and the square root of 36, 36 is a perfect square, so the square root of 36 is 6. I get I times 6. But we prefer, since this turned out to be a whole number right here, square root of 36 is a perfect square, we prefer to write the 6 in front of the I. So the answer is 6i. And so that's the square root of negative 36. Square root of negative 36 is 6i. So if I had the square root of a negative 25, then real quickly you should be able to say the square root of 25 is 5, and then there's a negative 1 here, so it's going to be that imaginary unit I. So real quickly, at some point, you should be able to see that that is just 5I. Now for right now, this is what you do. You would say, all right, well I know that negative 25 is the same thing as saying negative 1 times 25, and I know that I can write this as a product of negative 1 and the square root of negative 1 and square root of 25. And the square root of negative 1 I know is the imaginary unit I, and square root of 25 is 5, so I get 5I. Alright, now we'll come back and talk a little bit more about this, but let's talk about complex numbers. Complex numbers. Okay, so a complex number is a number that can be written in the form a plus bi, where a and b are real numbers. All right, a and b are real numbers. Okay, so now let's go back and talk about the number 16. Now, every number you've dealt with, you can even see it, sorry. So a complex number is a number that can be written in the form a plus bi, where a and b are real numbers. Now, every number you've dealt with, every number, all these real numbers you dealt with, those are complex numbers. See, like for 16 is a complex number because I can write any number in this form. So 16 is the same thing as saying 16 plus 0I, because 0 times I is 0, and 0 plus 16 is still 16. So notice this right here, see, it's in the form a plus bi, a plus bi, so 16 is your a and 0 is your b. So every number can be written in that form. 2.7, I can write 2.7 as 2.7 plus 0I. So all of these numbers, every number you dealt with, is a complex number. I can write in that form. We just wrote it as 16, 2.7, 2 and 7/10, and so on. Okay? Now, so if all you have is this, though, if I have 0 plus 6i, 0 plus 6i. Now notice in this case, a is 0 and b is 6. This is a 6. So a is 0, b is 6. So if a is 0, then the 6i right here, because 0 plus any number is that number, the 6i is called a pure imaginary number. It's still a complex number. It's still a complex number because I can write in this form, but it's a pure imaginary number since a equals 0. All right, so since a equals 0, it's called a pure imaginary number. All right, let's go back in and talk about the square roots of negative numbers. Okay, so let's simplify these. So here's some examples. Now this was going to need for what we're about to do with solving quadratic equations. So number 1, let's suppose I had the square root of, let's say, let me try and figure one. Let's see. Let's suppose I had the square root of 48. All right. Well, I know that so I'm trying to figure this thing out. All right. So I know that 48 is the square root of 16 times 3. And I know that I can write this as the square root of 16 times the square root of 3, which is 4 square root of 3. Okay? Alright, so that's kind of review from a previous lesson. Now, what if I had this? What if I had the square root of a, let's say, negative 16? Well, I can write, now remember, you're taking the square root of a negative number, so always remember the square root of a negative number, if you put that in your calculator, it's not going to be a real number. So that's where you get that complex number. In this case, so it is a complex number, but it'll be an imaginary number. So I can write this as the square root of negative 1 times 16, which is the square root of negative 1 times the square root of 16. All right, and the square root of negative 1 we know is I. The square root of 16 we know is 4, so the answer is 4i. All right, number 3. Suppose I had, let's say we wanted to find the square root of a negative 24. Negative 24. All right, well, let's do the same thing. So first of all, what I would do is I would take care that, since it's a square root of a negative number, I would take care of the fact that negative 24 can be written as negative 1 times 24. And so writing it as product of two radicals, I get this, and the square root of negative 1 I know is I. Now, square root of 24. 24 is not a perfect square, so it's not as simple as this one. It's going to be this idea here. So, square root of 24. Let's think of the largest perfect square that goes into 24. So the largest perfect square that goes into 24 is going to be, is going to be 4, because I can write 24 as 4 times 6. Now, just like we did before, I'm going to rewrite this as product of two radicals. So I get I times the square root of 4 times the square root of 6. And so this is 2 right here. Square root of 4 is 2. Now, here's how we write it. So remember, if you just have I times a whole number, then we tend to put the whole number in front. Okay? Here we have I times a whole number times a square root. So the way we write it is this. We put the I between 2 and the square root of 6. So we'll say 2I square root of 6. So that's how it's going to be written. That's how we normally write it. So don't forget. So it's kind of like this right here, where we had 4I. We put the whole number in front of the I. Same thing here. The whole number's in front of the whole number factors in front of the I, and then the square root factor is in back of the I. All right, so just like this. All right, number 4. Suppose we had, let's see. Suppose we had the 8 square root of a negative 63. 8 square root of a negative 63. All right, so again, we're going to do it just like this. So I have 8 times the square root of negative 1 times 63. And so I get 8 square root of a negative 1 times the square root of 63. So we're going to write this part here as two products. And I know that square root of negative 1 is I. So I get 8I square root of 63 at this point. Okay? Now, let's simplify the square root of 63. Let's think about 63 for a moment. If you need to, just go off to the side and do that. So the perfect square that goes into 63 will be 9. Because 9 times 6 is, 9 times 7. 9 times 7 is 63. Okay? And so I can write this as the square root of 9 times the square root of 7, and the square root of 9 is 3, so I get 3 square root of 7. All right, now that's this right here. So look at what we get. We get 8I times times 3 times the square root of 7. And so 8 times 3 is 24. 8 times 3 is 24. So we get 24I square root of 7. So that's what I get there. All right. Now, again, you can always check your work, and here's how you could check this. Now, first of all, you have to recognize that the square root of a negative number is where this I comes from. And then if I do 24 times the square root of 7, let's say 24 times the square root of 7. All right, so 24 square root of 7 is about 63.4980, let's say. And then over here, this is 8 square root of 63. Don't forget, let's just not worry about the negative because that's that I. 8 square root of 63, so 8 square root of 63 is 63.4980 and so on. And that's what we got here. Okay, let's look at number 5, the square root of a negative, let's say 4. So the square root of a negative 4, you should recognize right away that that is 2i. And again, if you can't, then just rewrite it. Say that's going to be the square root of a negative 1 times 4. So the square root of a negative 1 times the square root of 4. So that's I times 2. Remember, square root of negative 1 is I. And so I get 2i. Right, so then, number 6, suppose I had the square root of a negative, let's say, 31. All right, so that's going to be the square root of a negative 1 times 31. And I'm rewriting it as product of two radicals. So that's square root of a negative 1 times the square root of 31. Square root of a negative 1 is I. 31, I cannot, besides 1, there's no perfect square that goes into 31. All right, so that's what I get. Now, here's how you write this one. Okay, now you can leave it like this. Now, that's fine. Say I square root of 31. Or, now here's how you would probably see it written. You would probably see it written as square root of 31i. Now, if you write it like this, if you put I in the back like this, now this is how it's normally written. But if you put I in the back, just make sure it doesn't look like it's under that square root. So to be on the safe side, put I in front. Leave I in front, just like you did here. See how you had the whole number factor in front of I and the square root factor in back? Do the same thing here. So leave it like this. Now, if you write it like this, it's no big deal. But if it looks like that I is under the square root, it's not correct. All right, so be on the safe side, leave it like this. This is how it's going to be normally written if you were to check your answers in the back of the book. Okay, number 7, let's suppose we had, let's say, the square root of a negative 144. Square root of negative 144. Well, that's going to be, well, some of you might recognize that that's just 12i. All right. But if you can't, then you say square root of a negative 1 times 144. So that's the square root of a negative 1 times the square root of 144. Square root of a negative 1. Square root of a negative 1 is I times square root of 144 is 12. So you get 12i. All right, let's see. Suppose we had, all right, number 8. Okay, suppose we had, let's see. All right, suppose we had the square root of a negative 180. Square root of a negative 180. Okay, well, same idea. You're going to say square root of a negative 1 times 180, which is the square root of a negative 1 times the square root of 180. And square root of negative 1, you know, is I. Now, let's simplify the square root of 180. So let's just deal with that right here. 180, square root of 180. Well, what perfect square goes in 180? No, obviously 9 goes in 180, but that's not the largest. Now, you could use 9. There's nothing wrong with using 9. For example, I'll show you that. If you use 9, you're going to get the square root of 9 times 20. All right, nothing wrong with that. And if you go further, that's the square root of 9 times the square root of 20. And the square root of 9 is 3. So it looks like you get 3 square root of 20. But remember, you got to simplify. 20, besides 1, there is another perfect square that goes into 20, and that's 4. So you want to say, you got to simplify that further. So that's going to be 3 times the square root of 4 times 5. So that's 3 times the square root of 4 times the square root of 5, rewriting it as product of two radicals. So you get 3, and the square root of 4 is 2, square root of 5, and then 3 times 2 is 6. So you get 6 square root of 5. All right. Now, the quicker way to have done that was if you notice 9 and 20. So if you had said 9, the square root of 9 is 3, so you knew that was going to be a perfect square. But you also know that if you had 9 times 20, since 4 goes into 20, you could, and 4 is a perfect square, you could have said 9 times 4 is at 36. And so you could have said right here, you could have said, well, that's going to be the square root of 36 times, and all you have to do is just figure out 36 times what's 180, so you can say 180 divided by 36, and you get 5. So that's 5, and so you get the square root of 36 times square root of 5, and the square root of 36 is 6, you get 6 square root of 5, which is what this was. All right, now that goes here. So the square root of 180 is 6 square root of 5. Now the question, remember how you're going to write this. It is best to put the whole number factor in front, so it'll be 6i in front of I, and then the square root factor in the back. Oops, that's a 5. And there's your answer. All right, now let's look at this one, number 9. All right, number 9, suppose you had, suppose you had 3 square root of negative 32. 3 square root of negative 32. Okay, so it's very similar to something you had in a previous lesson, except this time the radicand is negative. So remember the I, that's where that imaginary unit comes into play. So that's going to be 3 times the square root of negative 1 times 32. So that's 3 times the square root of negative 1 times the square root of 32. So that's 3, and the square root of negative 1 we know is I. And then for square root of 32, I know that I can write this as 16 times 2. So that's going to be square root of 16 times the square root of 2. So that's 4 square root of 2. So that's going to go here. This is 4 square root of 2. So remember, all this is being multiplied together. And then what you want to do is rewrite 3 times 4 as 12. So it's 12i square root of 2. So that's how you're going to write the answer. Don't leave it like this. We expect you to know that 3 times 4 is 12. All right, number 10. All right, now here's another one you got to remember. So in a previous course, let's just look at just, not this one's not going to be a square root. In a previous course, you remember when you had this problem, and the notation looks like this. And basically what that meant was this right here. One way to read it was that I am taking the opposite. I'm taking the opposite of negative 8. I'm taking the opposite of negative 8. And so the opposite of negative 8 is a positive 8. So here, when you had this, the answer was just 8. All right? Now, if I had this, the opposite of the square root of 16, you had that in a previous lesson. So the opposite of the square root of 16, or negative square root of 16, is just a, we'll do that here, is just a negative 4. So the answer here was negative 4. All right, so for another one like this, suppose I had the negative square root of 25. So that would be just a negative 5. If I had this, negative square root of negative 25, though, negative square root of negative 25, then that would be negative. Now remember, square root of negative 25, if you just kind of work on that on the side, that is square root of negative 1 times 25, which is square root of negative 1 times square root of 25, which is I times 5, which is 5i. So that becomes negative 5i. So negative. And then, so remember, this is a negative part, and then the square root of negative 25 is this little part right here. All right, 14, real quick. Suppose you had this, negative square root of a negative 49. So you know that your answer is going to be a negative and the square root of a negative 49. Some of you note 7i. If you note 7i, then you write it. So it'll be minus 7i. But if you can't figure out right away, then do this part right here. So that's going to be square root of negative 1 times 49. So that's square root of a negative 1 times square root of 49. Square root of negative 1 is I. Square root of 49 is 7. That's an I here. Okay, and so you get 7i. Now that goes here, 7i. So the answer is a negative 7i. Okay, that's about all you need for what we're about to do. So you should be okay if you can go back and redo those 14 problems we just did.